Hello friends, in this second lecture of microprocessor, we are going to learn about the functional block diagram of generic microprocessor and then the features of 8085. So here in front of you, this is functional block diagram of generic microprocessor. As we learned in the last lecture, there are three main components of microprocessor. First is ALU, another is resistor, and third one is control unit. So you here clearly seen this part. The first part is ALU, first block, which consists of main three components: adder, complement and shifter, and status register. So adder performs the operation of addition, complementer and shifter, which performs 2's complement operation as well as shifting operation, and status register stores the answer with accumulator, because the total answer which is performed on the data cannot be shown by accumulator only. It is indicated by status register. Then the register section of every microprocessor consists of accumulator, that is the main register, because this register accepts the data before operation and stores the output after the operation first, and then it is passed to either memory or input output port. Then the next is temper register, which hold the temporary data during operations. Suppose like we want to make borrow, we want to make carry, so that will be stored by temper register. Then next are general purpose register, which is shown by HL. So there as per generation there are different general purpose registers. Next is program counter. This is important register which hold the address of next instruction to be executed. Then next is stack pointer. Stack pointer holds the address of stack top, that is the last instruction filled by the programmer. Then instruction register, which actually contain the opcode or instruction code, and instruction decoder, which decodes that code. These are main registers belong to microprocessor. So you clearly seen there are different buses like data buses, address buses, and that are connected with all this. So the third section is timing and control. The timing and control section, which belongs to different interrupts, then different control signals, and it is handled by a clock signal. The clock frequencies also depend upon the generation of microprocessor, which clock is to be used. So this is in all the functional block diagram of generic microprocessor. You have to draw this block diagram in your notebook. Question may be asked for 3 marks in the exam, board exam. Draw the functional block diagram of generic microprocessor. So after learning this generic microprocessor, we are going to learn more about the second generation microprocessor. Now the question arises in your mind that why we have to learn second generation, why not the fifth generation, or that what the processor we are using just now. It is the reason behind it is that the second generation microprocessor was the first programmable device which is used as a processor in computers, in desktops or in machines. So we have to learn it first, then we get the clear idea how to write the programs, because in our syllabus we have programming of 8085, total all components, internal block diagram of 8085. So the second generation microprocessor 8085 that we have to learn in detail. It is very important IC 8085. In second generation there are different number of processors, as we discussed earlier yesterday. We have Intel cells IM6100, Toshiba's T8190, then Intel's 8080 also. So each one have different characteristics of address buses and data buses, but the prominent IC, which most important IC, is 8085. What are the main features of this 8085 are? It is 8-bit microprocessor. So it can process 8-bit data. Second, it works on plus 5 volt DC power supply. Okay, so the power required to it is just plus 5 volt. It work on 3 megahertz to 5 megahertz frequency. So that clock is also important. It may be asked for the fill in the blanks. Then The next important thing is, though it is 8-bit processor, its address capacity is 16-bit, so it can address 2 raised to 16, that is nearly about 64 kilobyte of memory, which is very large at that time. Now you can see even your pen drive is more than GB, but at that time 64 kilobyte memory is very important. The next important thing is that it uses 256 input output ports, different which is used for different input or output devices. Then the next important thing is that it is available in 40 pin DIP package in single IC. Then it has 74 instructions for instruction set for programming. Then it has different interrupts, hardware and software interrupts, that we will discuss later on. The technology used to build this IC is NMOS technology, so which is related to semiconductor. So these are the important features of 8085 that we have to remember. At least we have to write 6 important features for this. So in the next lecture we are going to see about the pinout of 8085, what different pins, 40 pins we have discussed, that we got 40 pin IC. So how that pin are distributed, what are function of each pin, that we are going to see. Thank you.